Hello everyone, this is Dr. Sarala from Universiti Hussein, Malaysia, and my co-researcher is Ms. Venosha from Universiti Malaya. Today we would like to share our research entitled Design of Collaborative Learning Approach-Based Activities in the Malaysian Lower Secondary Science Textbooks. Ladies and gentlemen, the latest science curricula in Malaysian secondary schools follow the Integrated Curriculum for Secondary School (KSSM), which is designed to develop students' scientific knowledge, skills and competencies, and attitudes and noble values. The textbook designers have also significantly increased the number of projects and group works in the lower secondary science textbooks to allow for more student-centered active learning. This initiative falls in line with the current Malaysian education blueprint's aspiration to foster unity and inclusiveness through education and to create a richer and more conducive science learning environment for students. So, why collaborative projects and group works? This move is aimed to improve students' tendencies to work independently and collaboratively with teachers, peers, and community members for science activities. By involving in science projects, students get to participate in activities that require small-scale research with peers. They get to work collaboratively to gather information, evaluate data, and present findings or products to their instructor, class, or public. Group work, on the other hand, can be utilized for activities that simply require students to perform tasks collaboratively without conducting research or developing a product. Group works provide a great opportunity to develop students' science process skills, soft skills, and attitudes. Compared to projects, group works are lesser demanding in terms of time and resources. Ladies and gentlemen, the instructional design process of designing the latest Malaysian school science curriculum with increased emphasis on collaborative learning activities such as projects and group works has not been extensively researched. This presents a knowledge void gap in the area of school science curriculum and syllabus design and evaluation. Secondly, literature on collaborative learning practices for the school science subject in Malaysian schools seem to indicate that teachers focus more on classroom discussions during group work. Little evidence shows teachers utilizing other strategies such as facilitation, feedback, and reflection to carry out group work and projects for science. This provides the gap for the current literature review. Thus, in this study, the group works and project activities in the lower secondary science textbooks are explored from the lens of social constructivism theory, which acts as a guide for the collaborative learning approach. Generally, this study aims to inspect the scientific learning activities suggested in lower secondary science textbooks under the subsection called Activity for each topic. This subsection guides teachers to conduct group work, pair, or individual activities for students in classrooms. Specifically, this study aims to answer the research question: to what extent do the project and group works suggested in the lower secondary science textbooks follow the collaborative learning approach? Let me share the methodology for this study. Lower secondary science textbooks following the KSSM syllabus were analyzed using the conventions of qualitative content analysis (QCA). QCA is a flexible analytical method that results in meaningful and conceptual descriptions of data. The science learning activities in each chapter were explored based on their designs. A total of 65 activities were analyzed from the Form 1 textbook, 75 from the Form 2 textbook, and 63 from the Form 3 textbook. The findings were elicited to be deductive for the content of this study, and a QCA was conducted in three sequential phases. First, preparation, second, organization, and third, reporting. The software used to conduct the QCA was called QDA Mindlight, which was available online for free. Ladies and gentlemen, to understand the implementation of scientific learning activities and make appropriate suggestions for improvisations, it is vital to identify the extent and components of science. Ladies and gentlemen, to understand the implementation of scientific learning activities and make appropriate suggestions for improvisations, it is vital to identify the extent and components of such activities in the textbooks. The table beside shows the categorization and breakdown of all the activities found under the activity subsections in the lower science textbooks based on the theoretical understanding of the collaborative learning approach. At the first level of categorization, activities were categorized as group work or group projects based on phrases such as in a group, work collaboratively, work with a partner, or this is a group work. The findings show that, in an overview, 56.8% of learning activities in the lower secondary science textbooks were designed to be group and pair works, while 43.2% were individual activities. Exploration, memory, and application-based learning activities were found to be mostly designed to be conducted with peers in a classroom. Apart from the need to engage young learners in interactive and active learning activities, space and time constraints could also be a reason for a huge volume of science group works. Secondly, the strategy of active interaction was found to be more prevalent compared to other collaborative learning approach-based strategies. Furthermore, interactions only seem to be expected to take place among peers in a classroom. Other potential collaborative learning participants, such as teachers, parents, social media connections, and community members, could also be included as well. Next, as for active facilitation, it was noted that the activities did not clearly specify instruction for a teacher's or a peer's role as a facilitator or co-facilitator respectively. The teacher's version of science textbooks did not provide additional instruction sufficiently for an explanation of instructions, demonstration of expected outputs, or scaffolding techniques for the activities. A majority of activities were designed for students to gather information on their own before the activity or in the classroom using ICT tools. The activities seem to encourage students to be more independent in performing the learning activities as opposed to being interdependent with their peers and teachers. In a nutshell, the study shows that the activities designed for project and group work in the lower secondary science textbooks in Malaysia do not seem to be very much in line with the theoretical understanding of the collaborative learning approach. This could be a challenge for teachers who might lack guidance or theoretical understanding of the ways to effectively conduct these activities in real classrooms. The national science textbooks can be revised to allow for more evidence and theory-backed content so that they can be studied and evaluated from time to time based on classroom and policy needs. This would help lower the teachers' workload in improvising their teaching learning materials as well. Therefore, future studies are recommended to include more observations and reports on the classroom practices of the science textbook activities in various Malaysian school settings for more robust findings. Ladies and gentlemen, with that, we thank you. Have a great day ahead. Bye.